Hello, grade 8s. This is our first lesson on Pythagoras' theory, or the Pythagorean theorem. So what did Pythagoras discover about right triangles? Of course, this is a right triangle. Just you should know that this side here is called the hypotenuse. It's always the longest side. You find the right angle, go directly across. That's your longest side. The other two sides are called legs. It doesn't matter which is called a leg. They're both legs. All right? So here's what he discovered in a nutshell, that if you attached a square to each side of a right triangle, this is called a vertical leg, this is called the horizontal leg, this is the hypotenuse, of course. So if we put a square on there, you notice that the area of this hypotenuse square is 25 square units. The area of this horizontal square is 16 square units, and the area of the vertical leg square is 9. He noticed something very interesting. And if you can make the connection there, you can see it. He found that when you add the areas of the two leg squares, it equals the area of the hypotenuse square. So 9 plus 16 is 25. And that happens for all right angled triangles. Okay, so 9, 16, 25. The area of the two smaller patios, as we called it in class, together equal the same area as the biggest patio on the hypotenuse. Okay, so this allows us to solve questions like this. So what's the area of the unknown square? Where this is a leg, that's a leg, right? So that area and that area equal that one. So this unknown is 20 centimeters squared. Okay, so this one here, we have this square and this square. That one we don't know, but these are legs. So these two will add up to give you the bigger one. So 23, 14, that is 37 centimeters squared in area. This one here, okay, we cannot add these two to get that one because this is the biggest one. It's the hypotenuse square. So this one will equal to this plus this. So how do we find this? Well, simple. We can subtract 45 minus 15, right? And that will equal this. So that one has to be 30 centimeters squared. This one here, do we add or take away? Well, that's a leg. We're missing a leg square, so we take the largest minus the smallest, right? 88 minus 24. Hypotenuse square minus leg gives us the missing leg, so that looks like it would be 64 centimeters squared for that missing square, right? Quickly moving along. So what if the area of the two smaller squares don't equal the area of the large hypotenuse square? So in this example, this is the leg, that's a leg. Well, 80 and 40, if I added that, that equals 120. However, that says 100. What does that mean? Well, what that means is that this triangle is not a right triangle. Pythagoras found in order for it to be a right triangle, 90-degree triangle, it has to be that the two leg squares are the same size as the larger hypotenuse square. So this triangle, in fact, would maybe look like this. It would not be a right triangle. Okay, so is this a right triangle? Take a quick look, stop the video if you have to. The answer is yes. These two leg squares add up, 38 and 22 equals 60. So the answer is yes. This one here, take a look. Is this a right triangle? And the answer is, it is not. Because these two leg squares add up to 60. So this one is only 58. So it's not quite a right triangle. So in conclusion, if you add the areas of the two leg squares together and it equals the area of the hypotenuse square, then you have a right triangle. If you add the areas of the two leg squares together and it doesn't equal the area of the hypotenuse square, then you don't have a right triangle. So, almost to the end here. So here's a question. Here's the three squares. Notice these are not areas. These are just lengths of the leg, and hypotenuse, longest side. So what's the area of each square? Well, we learned that in order to find the area of a square, you have to take the length and you square it. That's what you do. You square the length. So this one we go 10 times itself, right? So we go 10 squared. That's 100 centimeters squared. This one here, we have to go 6 squared, so that one's 36 centimeters squared. And this one here is 8, so we have to go 8 squared, and that's 64 centimeters squared. And that's how you find the area of those squares, once you know the length. Okay, what's the length of each square? Well, this is opposite, so I'm giving you the area. How do we find out the length of this leg? Well, we know the area, and you learned that if you square root area, you get length. So I square root 25, and I get 5 centimeters, not squared. Here I square root, for this one, I square root 49, so that equals 7 centimeters. And this one here, well, it's not going to be a perfect square root. Square root 74, well, that's going to be a decimal, right? So this square will be 8.6 centimeters long, roughly. All right, and that's that. So remember, to find the area, to find the length of a square, you square root the area. Okay, so what's the length of the unknown square? Look at this question. Well, that's an area. That's an area. I know this one has to be those two added up. So this square has to have an area equal to 196 centimeters squared. To find the length, the missing side, I square root 196. So that equals 14 centimeters. Right? That's how you find the missing length. This one here, well, this is a leg square. So to find the area of that, I have to subtract. So 225 minus 104, well, that equals 121. So this square is 121 centimeters squared. To find the length, I square root it. So that equals 11 centimeters long. That square is 11 centimeters. And that is our last page. Really quickly, I hope you enjoyed the video and I hope you learned. Have a good day.